Small earthquake shook Mount Hood today, but experts say there's not anything to worry about yet.
Are just above freezing, currently 31 degrees, but notice the camera right now. It is.
Over the past month, 23 earthquakes have rattled Oregon's Cascade Volcanoes, leaving scientists and locals wondering what's going on. Are these long, quiet volcanoes starting to stir? Or is it just business as usual for the Earth's crust? In this video, we'll dig into the data, revisit the epic eruptions of the past, and see what it all means for the Pacific Northwest. Mount Hood. Oregon's tallest peak, Mount Hood, towers at 11,250 feet and has been the center of attention lately. Over the past few weeks, it's been the most active of the Cascade Volcanoes, with 14 earthquakes recorded in its vicinity. You can even see this glacier-covered giant from downtown Portland, a breathtaking sight, but also a reminder that beneath all that beauty lies a restless powerhouse of nature. Today, Mount Hood is an outdoor enthusiast's dream, drawing skiers, snowboarders, and hikers to its slopes year-round. But if you'd visited this same mountain back in the 18th or 19th centuries, you might have thought twice about getting anywhere near it. Mount Hood was far from the calm, snowy peak we know now. Over a span of 16 years in those centuries, it erupted multiple times, not massive, world-ending eruptions, but enough to send plumes of ash into the sky and trigger destructive forces that reshaped the landscape. One of the most haunting examples of Mount Hood's power happened in 1781. About 32 miles from the mountain, a peaceful forest met its doom, not through fire or logging, but by being buried alive. A massive lahar, a volcanic mudflow, raced downriver, fueled by melted glacial ice and volcanic debris. It wasn't just any mudslide. It carried so much sediment that it formed a 14-foot thick layer that swallowed the forest whole. To make matters worse, this surge of mud and debris raised the river's flood levels by an extra foot, wiping out everything in its path. Over time, erosion exposed the tree graveyard, with the trunks still eerily preserved, standing as a silent warning of Mount Hood's ability to wreak havoc. This wasn't an isolated event either. Lahars are one of the most dangerous hazards linked to Mount Hood. Its glacier-covered summit means that even small eruptions have the potential to unleash torrents of volcanic mud and debris, which can travel quickly and cause destruction dozens of miles downstream. Lahars are one of Mount Hood's most infamous calling cards. These fast-moving volcanic mudflows are triggered when the intense heat from eruptions melts parts of the mountain's massive glaciers, about 380 million cubic meters of ice. The resulting slurries of water, rock, and volcanic debris surge through rivers, carving up the landscape and sometimes wreaking havoc on communities downstream. One place particularly at risk is Troutdale Airport, which, believe it or not, sits right on top of ancient lahar deposits. That means the area has already been hit by one of these destructive flows in the past. If Mount Hood were to erupt again, the airport and the surrounding area, including about 7,500 residents and countless businesses, could face the same fate. It's a sobering thought for anyone living in the shadow of this powerful volcano. Mount Hood's last eruption was in 1866, but don't let that fool you into thinking it's a sleepy mountain. It's officially ranked as the 6th most hazardous volcano in the US, and scientists keep a close eye on it. Like its fellow Cascade Range peaks, Mount Hood owes its fiery existence to the tectonic drama of the Juan de Fuca Plate diving under the North American plate. This subduction process fuels magma production deep underground, which occasionally makes its way to the surface in spectacular and sometimes destructive fashion. Geologically speaking, Mount Hood is an ancient marvel, with its origins going back about 500,000 years. In its earliest days, eruptions occurred through several vents scattered across a 5-mile wide area. These eruptions created thick andesite lava flows, forming the mountain's solid foundation. Over time, repeated eruptions piled more layers of lava, ash, and debris onto this base, eventually building the iconic stratovolcano we see today. But Mount Hood's story is far from over. The glaciers that drape its peak today act as both a stunning visual feature and a potential hazard. When magma rises during an eruption, it can quickly melt that ice, setting the stage for massive lahars. These mudflows don't just stay close to the mountain, they can travel dozens of miles, following river valleys and devastating anything in their path. And since Oregon's rivers are vital to nearby communities, the risks of a Mount Hood eruption extend far beyond the mountain itself. While Mount Hood may steal the spotlight, Mount Jefferson, just a bit south, has its own fiery past and is still keeping us on our toes. Mount Jefferson. Mount Jefferson, Oregon's second highest peak, stands tall at 10,502 feet. And while it may not get as much attention as Mount Hood, it has its own fascinating and fiery story. Located about 50 miles south of Hood, this glaciated beauty might look serene with its snow-covered summit, but its history is anything but calm. Recently, it's been in the spotlight with 3 small earthquakes recorded nearby, reminding us that it's still a player in the Cascade Range's volcanic lineup. Mount Jefferson has been shaped by a mix of fire and ice. Over millennia, glaciers have carved its rugged features, giving the volcano its dramatic, sculpted appearance. But underneath that icy exterior lies a history of eruptions, with 3 occurring since the last ice age. The most recent one happened just 1,000 years ago. Not exactly ancient history in geologic terms. While there's some speculation that Jefferson might be entering a dormant phase, scientists aren't ready to call it quits just yet. It's still classified as an active volcano, and its potential to wake up again is very real. What's especially interesting about Mount Jefferson is that the iconic peak is just one part of a much larger volcanic system. The entire complex stretches 11 miles long and 5 miles wide, encompassing a variety of volcanic features. Lava domes, ancient subglacial vents, and cinder cones dot the area, each with their own story of fiery activity. Some of these smaller vents and cones flared up briefly in the past and then went silent, but their legacy remains etched into the landscape. The southern part of the Mount Jefferson complex has been the hotspot for activity in recent times, geologically speaking, of course. All 3 eruptions of the Holocene epoch happened here, at various cinder cones. These eruptions spilled out basaltic and andesitic lava flows that blanketed more than 8 square miles of terrain. If Mount Jefferson were to erupt again, scientists believe it would most likely come from this southern region, potentially forming yet another cinder cone. Mount Jefferson's towering, rugged appearance tells a story that stretches back to its ancient beginnings and long periods of dormancy. The main part of the mountain hasn't erupted in about 15,000 years, but its volcanic roots go much deeper, around 280,000 years deep back in the Middle Pleistocene era. It's had a long, tumultuous history of eruptions and quiet spells, all of which have shaped the mountain we see today. The story of Mount Jefferson really kicks off with the subduction of the Juan de Fuca plate beneath the North American plate. This constant push and pull of tectonic plates forced magma to rise, sparking a chain reaction of volcanic activity. In the early days, the eruptions were incredibly explosive. We're talking massive blasts that created a crater about 1,000 feet wide. These early eruptions sent ash shooting into the sky and triggered pyroclastic flows, those fast-moving clouds of hot gas and ash that can obliterate everything in their path. As the andesite lava poured out, it began to build the foundation of what would become the southern and western parts of Mount Jefferson. For tens of thousands of years, Mount Jefferson wasn't all about constant eruptions. It had intense volcanic activity, followed by long stretches of quiet time where the mountain calmed down, only to stir again. One of the most significant eruptions occurred around 75,000 years ago. This event was so powerful that it sent ash flying as far as Arco, Idaho, 430 miles away. It was an eruption on an epic scale, wiping out all life within a 5-mile radius and leaving thick layers of ash scattered across the region. After this, the volcano calmed down for a bit before erupting again over the next 60,000 years, building the upper 3,000 feet of the mountain. These eruptions slowly shaped the summit into what it is today, with the most recent volcanic activity occurring about 15,000 years ago. That was the last major phase of Mount Jefferson's construction, and after that, things started to quiet down. In more recent geological history, the volcanic activity shifted to the southern part of the mountain, where it has been more focused in recent eruptions. During the Holocene epoch, 3 younger cinder cones have erupted, adding to the volcanic legacy of Mount Jefferson, but in smaller, localized bursts. These cones mark the most recent volcanic events though they've been much less dramatic than the early explosive eruptions that built the bulk of the mountain. Mount Jefferson hasn't been quiet throughout its history, quite the opposite actually. Its most recent eruptions have left behind some pretty striking features. The first major eruption happened around 6,500 years ago, and it was a spectacle. Lava fountains shot up to 1,000 feet in the air, creating an epic show of molten rock. Over the next few weeks, blocky lava flows surged down the valleys carved by glaciers, transforming the landscape and leaving behind rough, jagged rock formations that are still visible today. Then, about a century later, another eruption took place, this time creating a new cinder cone and a massive lava field that stretched about 2 miles to the southwest. These eruptions weren't small events. They really reshaped the surrounding area, leaving layers of lava that have solidified into rock over the millennia. The most recent eruption occurred around the year 1000, when the South Cinder Peak cone was formed. This event wasn't as massive as some of the earlier ones, but it still packed a punch, depositing nearly a square mile of fresh lava. While the lava flows from these eruptions didn't travel too far, no more than 7 miles from their source, they've had a lasting impact on the local landscape. You can still see the scars of these flows and the new volcanic features they created when you explore the area today. But the real danger from Mount Jefferson isn't just the lava. If the main cone were to erupt again, there's a very real risk of melting huge sections of the mountain's glaciers. That's where things could get really destructive. The heat from an eruption could send massive amounts of glacial meltwater rushing down the slopes, mixing with volcanic debris to form lahars, devastating mud flows that could destroy everything in their path. These lahars can travel surprisingly far, up to 50 miles from their source, which puts communities and infrastructure at risk. In fact, around 15,000 people live in areas that could be threatened by a future lahar, making this a significant hazard to consider. While Mount Jefferson has its threats, Crater Lake offers a whole different kind of volcanic story, one that's peaceful now, but wasn't always this calm. Crater Lake. Right now, Crater Lake in Oregon is as peaceful as it gets. For the past 4 weeks, there haven't been any earthquakes recorded nearby, which adds to the sense of calm. But beneath those calm blue waters lies a fascinating and kind of terrifying history. Crater Lake wasn't always this tranquil. It's actually the remnant of Mount Mazama, a volcano that erupted in a truly catastrophic way about 7,700 years ago. That eruption was one of the biggest in North America's history, so huge that it caused the entire summit of the mountain to collapse, creating the massive caldera we see today. It was an explosive event that sent tons of ash and pyroclastic material flying through the air, covering the surrounding area and leaving behind a lasting geological mark. After the eruption, the caldera slowly filled with rainwater, creating Crater Lake, the deepest lake in the United States and one of the deepest in the world. Today, the lake is a serene spot, attracting visitors from all over to take in its breathtaking beauty. But when you look at the stillness of the water, it's hard to forget the violent eruption that formed it. The calm surface hides the intense volcanic history that shaped the area, and it's a stark reminder of just how powerful and unpredictable volcanic activity can be. Though Mount Mazama has been relatively quiet for thousands of years, scientists still keep a close eye on the area. They're monitoring seismic activity around Crater Lake to stay on top of any signs that the volcano might wake up again. Right now, there's no immediate threat of an eruption, but given the explosive past of Mount Mazama, it's never a certainty that the quiet will last forever. While Crater Lake remains peaceful, Mount Rainier just a bit further north tells a much more intense and dangerous story. Mount Rainier. At 14,411 feet, Mount Rainier isn't just the tallest peak in Washington, it's also one of the most dangerous volcanoes in the United States. With its towering snow-capped slopes and massive glaciers, Rainier's beauty is undeniable. But the real threat comes from its location, right next to heavily populated areas like Seattle and Tacoma. That makes it not just a majestic landmark, but a volcano that has people on edge. As an active stratovolcano, Mount Rainier has been erupting for thousands of years. The last eruption was around 1,000 years ago, and since then, things have been relatively quiet. Still, the mountain isn't exactly asleep. There are still signs that it's far from done, things like seismic activity, ground deformation, and volcanic gas emissions. These are subtle reminders that Rainier still has the potential to blow its top at some point in the future. One of the biggest risks associated with Mount Rainier isn't necessarily the eruption itself, but the lahars, volcanic mudflows, that could come with it. These lahars could happen if there's an eruption, or if the intense heat from an eruption starts rapidly melting the glaciers on the mountain. When the glaciers melt, they mix with ash and debris, creating mudflows that could race down the valleys surrounding the mountain, causing serious damage to communities and infrastructure. These mudflows can travel long distances, making the threat even more dangerous. Even though eruptions are rare, the potential impact of a future eruption could be huge. That's why Mount Rainier is constantly monitored by scientists who keep a close eye on seismic activity and other signs that could indicate a possible eruption. While Mount Rainier poses serious risks, Mount St. Helens has already made its explosive mark in history with one of the most memorable eruptions ever. Mount St. Helens. When Mount St. Helens erupted on May 18, 1980, it sent shockwaves through the world. The explosion is still one of the most well-known volcanic events in US history. For weeks leading up to the eruption, there were signs something was brewing. Lots of seismic activity and small earthquakes that had everyone on edge. Then, the mountain erupted in spectacular and destructive fashion, causing widespread damage that completely reshaped the landscape. It was the biggest volcanic eruption in the US in over a century, and it changed the area forever. The eruption wasn't just loud, it was absolutely catastrophic. The mountain's summit was blasted away by the force of the explosion, losing more than 1,300 feet, 400 meters, in height. That's like taking a giant chunk out of the top of a mountain. Pyroclastic flows, superheated clouds of ash and gas, rushed down the mountain, and massive ash clouds rose into the sky, darkening the surrounding areas for miles. Lahars, or volcanic mudflows, swept down the valleys, destroying everything in their path. On top of all that, the eruption triggered the largest landslide ever recorded, sending millions of tons of debris sliding down the slopes and scattering ash and rock across the region. Despite the destruction, the eruption offered scientists an incredible opportunity to study how volcanoes work and how they impact the environment. They were able to observe firsthand how ecosystems react to such a major disaster. Even in the devastation, life began to return, with new plants and animals slowly making their way back to the area over time. It was a rare, almost surreal chance for geologists and ecologists to see the rebuilding process in action. Since then, Mount St. Helens hasn't been totally quiet. While there haven't been any eruptions as dramatic as the one in 1980, the volcano is still active. Seismic activity continues in the area, and the mountain has had periodic eruptions and small bursts of activity. Scientists keep a close watch on it, knowing that while it may seem calm now, the potential for another eruption is always there. Monitoring continues to track any signs that the volcano could become more active again. While Mount St. Helens has made its impact, Three-Fingered Jack in Oregon's Cascade Range tells a quieter volcanic story. Three-Fingered Jack. Three-Fingered Jack is an old, beat-up volcano sitting in Oregon's Cascade Range, looking pretty rugged after thousands of years of wear and tear. It's a shield volcano, but with a twist. Thanks to heavy glaciation, it's now a jagged, eroded shell of its former self. This place really has the feel of something ancient, with its crumbling basaltic andesite lava flows from eruptions that happened way back in the Pleistocene, like 500,000 years ago. If you hike up to the summit, you'll find a narrow ridge made of loose tephra, which is basically just volcanic ash and debris. This ridge is held together by a solid vertical dike, a thick wall of rock about 10 feet thick. That dike is what's left after glaciers scoured away a lot of the surrounding rock, exposing this tough strip of rock that supports the loose stuff. It's like the volcano's version of an exposed bone under its weathered skin. Looking at the slopes, you'll see a mix of lava flows with minerals like olivine and augite basalt, suggesting that Three-Fingered Jack had a pretty complex volcanic history. Early eruptions built up a shield shape, but later eruptions added layers of lava and pyroclastic material, creating a steeper, more cone-like form. As you move around the area, there are a couple of other peaks nearby, like Maxwell Butte and Turpentine Peak, which didn't get as shredded by the glaciers, so they're in better shape than Three-Fingered Jack. Most of this volcanic drama happened way back, but the big shifts occurred during the Pleistocene, when glaciers came crashing through, scraping away much of the cone, especially on the eastern and northeastern sides. That's when you get those deep scars in the landscape. Parts of the volcano were almost completely removed, leaving behind the tougher stuff, dikes and plugs that tell the story of what used to be there. Now, Three-Fingered Jack is an old, dormant volcano, its last eruption happening a long time ago, between 500,000 and 250,000 years ago. It's been quiet for so long that it's hard to imagine it ever roaring to life again. While Three-Fingered Jack is showing its age, Mount Washington to the northwest tells its own story of erosion and volcanic power. Mount Washington. Mount Washington is an impressive, eroded volcano sitting in Oregon's Cascade Range, about 40 miles northwest of Bend. It's got this sharply pointed peak that reaches 7,794 feet, making it stand out in the landscape. The summit's cone is a mix of cinder, lava flows, and solid rock that's all been shaped by centuries of geological forces. The mountain itself is a classic example of a shield volcano, though over time, glaciers have done a lot of work eroding it down to what we see today. This mountain's profile is pretty typical for shield volcanoes, broad and gently sloping, which you get from lava that's pretty runny and flows easily, like basaltic andesite. When it erupted, the lava spread out over large areas, giving the mountain that signature low and wide look. But today, the summit is much sharper, crowned with a steep central plug, which is like a leftover chunk of the original volcanic conduit, the pipe through which lava used to flow. This plug hasn't erupted in ages though. The volcano hasn't had any major activity since the late Pleistocene. Glaciers have had a big hand in shaping Mount Washington, scraping away huge chunks of rock over thousands of years. This process has exposed the volcano's innards, revealing dikes that are now visible in the summit cone. It's like peeling back layers of a book, where each page tells a different chapter in the volcano's story. Mount Washington started to form during the late Pleistocene, with lava pouring out and shaping the land around it. The eruptions involved basaltic andesite lava, which is pretty common in the area. The volcano was pretty active back then, adding to the volcanic landscape that makes Central Oregon so geologically interesting. The most recent eruptions happened just about 300 years ago, when lava was pushed out of small spatter cones on the northeastern side. Just south of Mount Washington, you'll find another interesting feature of Oregon's volcanic past: Belknap Crater. Belknap Crater. Belknap Crater is a shield volcano tucked in Central Oregon's Cascade Range, near Mackenzie Pass. It's got that classic shield volcano look, a broad, gently sloping profile that makes it stand out. The volcano's made mostly of basaltic lava flows, which is pretty common for this kind of formation. These flows spread out in all directions, giving the mountain a laid-back, wide appearance instead of the steep, pointy peak you might associate with other volcanoes. One of the coolest things about Belknap Crater is the sheer amount of lava it's pushed out over the years. The lava flows stretch across nearly 100 square kilometers in the Mackenzie Pass area. What's striking is how little vegetation there is on the flows, which suggests these eruptions are relatively recent, maybe in the last few thousand years. It's like nature is still slowly reclaiming this space. The volcano's volcanic history goes way back, but the most recent eruptions happened around 1,500 years ago, around 480 AD. These eruptions sent lava flowing out from vents on the north and south bases of the volcano, reaching both the southwest and northwest. The flows helped shape the landscape around Mackenzie Pass, leaving a trail of rock that shows just how active the region has been. Off to the side, there's also a smaller shield volcano called Little Belknap, sitting on the eastern flank of the main crater. Little Belknap erupted about 2,900 years ago, sending more lava into the Mackenzie Pass area and adding another layer to the already dramatic volcanic landscape. It's like the little brother of the big volcano, still doing its part to shape the land. Today, Belknap Crater is considered dormant, with no eruptions recorded in the Holocene epoch. It hasn't erupted in a long time, but the lava flows and Little Belknap remind us of the volcano's active past. Not far from Belknap, there's another impressive feature in central Oregon's volcanic landscape: Mount Bachelor. Mount Bachelor. Mount Bachelor is a standout shield volcano in central Oregon, sitting just 20 kilometers west-southwest of Bend. It's the biggest volcano in a volcanic chain that stretches for about 25 kilometers, and it's got some serious volcanic company. Cinder cones, lava flows, and other cool features are scattered all over the area. It's hard to miss this massive peak that dominates the landscape. Like most shield volcanoes, Mount Bachelor has that classic, broad and gently sloping shape. That's thanks to the eruption of low-viscosity basaltic andesite lava, which flows out easily and spreads out over wide areas instead of building up a tall, steep peak. The lava from these eruptions has covered nearly 100 square kilometers in the Mackenzie Pass area. The flows are mostly bare, without much vegetation, which tells us they're relatively young in geological terms, maybe just a few thousand years old. The volcanic activity in this region didn't happen all at once. There were 4 major eruptive episodes that shaped Mount Bachelor and the surrounding volcanic chain. The earliest eruptions were widespread, stretching across the entire length of the chain, but the activity was especially concentrated in the middle, where the Sheridan Mountain Shield was built up. These eruptions laid the foundation for much of what we see today. The most recent eruptions took place around 8,000 to 10,000 years ago, with lava flowing out of the lower north flank of the volcano. These eruptions were smaller compared to earlier ones, but they still left their mark on the landscape, producing a scoria cone and fresh lava flows that added to the region's dramatic volcanic features. Continuing the volcanic journey through central Oregon, Newberry Volcano stands out as a massive force in the landscape. Newberry Volcano. Newberry Volcano is a massive, prominent shield volcano that's been shaping central Oregon's landscape for over 500,000 years. It's one of the most significant volcanic features in the region, and its long history is full of different types of eruptions that have left behind a truly unique landscape. Like many shield volcanoes, Newberry has that classic, broad, gently sloping profile. It got that way thanks to the eruption of low-viscosity basaltic lava that spreads out easily and forms wide lava fields. Because of this, Newberry has a sprawling volcanic landscape with an array of features, from vast lava flows to complex geological formations. It's a true example of how lava can reshape the land over time. One of the most striking features of Newberry is the calderas, massive depressions formed by explosive eruptions that caused the summit to collapse inward. Over time, these calderas were filled by lakes, like Paulina Lake and East Lake, which now sit within the caldera's lobes. It's incredible to think that the beautiful lakes in the area were once part of violent volcanic activity that reshaped the mountain. Newberry's volcanic history kicked off about 500,000 years ago when it began building its broad shield. The early eruptions were a mix of explosive blasts, creating ash deposits, and the slow, steady flow of lava that stretched across the land. As the volcano continued to grow, it laid down layers of lava and ash that built the foundation for what we see today. In the late Pleistocene, around 12,000 to 20,000 years ago, Newberry really went to town with some massive lava flows. These flows were so big that they spread for miles, reaching areas like Bend and Redmond. They filled canyons and completely transformed the regional topography, leaving huge fields of lava rock that are still there today. Then, in more recent history, Newberry had about 25 eruptions over the past 10,000 years. The most recent one, about 1,300 years ago, created the Big Obsidian Flow, a huge deposit of rhyolitic lava. This flow stands out because it's made of obsidian, the shiny black volcanic glass that gives the area a really unique look. It's a reminder that even though Newberry has been quiet for a while, it hasn't always been dormant. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.